Okay, welcome everyone. Welcome back to Critical Appraisal of Research Methods and Analysis, CARMA. And this is our last proper section of this course. And this part will be about influencing systems, intervening and investigating intervention. And let's go ahead and talk about that. But first, we need to just recap a couple of things from the last week. So what we talked about in relation to complex systems and component dominant dynamics versus interaction dominant dynamics. So here is another representation of that idea, where in component dominant dynamics you have this linear arrangement of stuff. So A causes B causes C, and then this causes human behavior. And this idea relies on finding these so-called efficient causes. So we have these all kinds of causes that can be separated from each other, and we can evaluate how much different cause affects a particular effect. Whereas in the interaction dominant dynamics, we have this human behavior coming out of interactions between many processes on different time scales in the body and in the environment, and of course in social systems too. And this can be a bit unintuitive if you have received limited academic training in particular fields of study, whereas it might not be that unintuitive if you hold some belief systems of some indigenous peoples or are very well versed in complexity theory or very advanced mathematical methods. So just to go back and think about, okay, so we talked about these the domain of complex systems, and we talked about complicated systems where this component dominance holds. And one way to view this is that we have these variables, the features of a problem, like social norms, for example, or roles and identities or whatnot. And then we have this interplay between those things, so that we could call a parameter. So how are health and physical activity related? What's the relationship between police presence and crime, and so forth. And we can think of this sort of change processes, because what we're thinking about when we're thinking about affecting systems and how to deal with them and how to solve problems, we're talking about change. So if we are in a situation where we have one stable attractor, we spoke about attractors at length last week, these variables and parameters are both stable. And then we could have a situation where we have several attractors and tipping points between them. And in this case, the parameters could be called unstable, whereas the variables might still be stable. And then in the last type, we have this evolving change where both of these are unstable and non-stationary, to use the terminology of last week, if you remember the three little bears. When we are in a context where this holds, we can use traditional statistics, and that is a very nice place to be in, because we can actually take evidence and use it for evidence from the past and use it for the future. Whereas in these situations, we might really need a alternative approaches. And there's something to be said about how stable something is. So in the Alex Ryan paper, emergence was defined as an increase in scope. So in this case, if we're thinking about temporal scope, we could see new features emerging. And one of those features could actually be failure of the system. So the quote here says that very much of what seems stable and rigid and reliable eventually wiggles, wobbles, and falls down if you watch it long enough. So this captures sort of the gist of the idea quite nicely, I think. And one interesting piece about this um, is that when you actually, if you actually try to force a system to be very non-volatile, what you might be actually causing is larger and catastrophic changes that eventually come out. So we have spoken about the illusion of stability in relationship to fat tails. So that in a fat-tailed situation, it might be that actually the very conventional things actually become more common, and the middle of the distribution gets disappears, and there will be more extreme events and more normal events. And we have also discussed context, and especially the difference between complicated and complex context. So just to wrap up very briefly, in complicated context, we have a modest number of components that are not very too interconnected or interdependent. Whereas in complex context, we have a large number of components and a relatively high interdependence between them. In complicated context, these behaviors change slowly. Culture and trends might take decades to transform, and we don't really need to worry about them transforming overnight. Whereas in complex context, these trends and fads and tropes can just catch fire and move very, very quickly, and social change might happen very fast. In complicated contexts, we have these relatively homogeneous actors, whereas or people, whereas in complex contexts, they are diverse, and they could be homogeneous within groups, but diverse across groups. So if you want to do communications, for example, you might be in some sort of a pickle because you suddenly have a huge number of target groups where you have to tailor your message to each one of those. And in complicated contexts, we have these problems that we can solve analytically. We can use recipes, step-by-step best practices. So first do this, and then you succeed. Whereas in complex context, we have these wicked problems, or at least the potential for a problem to be wicked, which or intractable rather. So a problem which doesn't have an obvious solution, which could be make everyone happy, but all solutions are incomplete in one way or another. And there is this sort of innovation and participatory explorations that need to take place all the time. And we talked about how the modern world has shifted more from complicated towards more complex decision-making contexts.